Alright, so I'm making this recording for myself and potentially to share with other people working at Lockheed or other systems engineers. So this is the INCOSE Systems Engineering Handbook, a guide for system life cycle processes and activities. This is just the introduction. So here's the cover. It's the 4th edition. Here's one of the pages, another page. The contents. Chapter 1 is Systems Engineering Handbook Scope. Chapter 2 is Systems Engineering Overview. Chapter 3 is Generic Lifecycle Stages. Chapter 4 is Technical Processes. Chapter 5 is Technical Management Processes. Chapter 6 is Agreement Processes. Chapter 7 is Organizational Project Enabled Processes. Chapter 8 is Tailoring Process and Application of Systems Engineering. Chapter 9 is Cross-Cutting Systems Engineering Methods. Chapter 10 is Specialty Engineering Activities. And then you've got the appendices. Appendix A is references. Appendix B is acronyms. Appendix C is terms and definitions. Appendix D is the n-squared diagram of systems engineering processes. Appendix E is input-output descriptions. Appendix F is acknowledgements. Appendix G is comment form, and index is 208, or it's just appendix, or the index. There's the notices. History of changes. Original was 1994. This most recent version is from 2015. I'll go ahead and read the preface here as well. So, the objective of the International Council of Systems Engineering, INCOSE, Systems Engineering Handbook, SEH, is to describe key process activities performed by systems engineers. The intended audience is the systems engineering professional. When the term systems engineer is used in this handbook, it includes the new systems engineer, a product engineer, or an engineer in another discipline who needs to perform systems engineering, or an experienced systems engineer who needs a convenient reference. The descriptions in this handbook show what each SE process activity entails in the context of designing for required performance and lifecycle considerations. On some projects, a given activity may be performed very informally. On other projects, it may be performed very formally, with interim products under formal configuration control. This document is not intended to advocate for any level of formality as necessary or appropriate in all situations. The appropriate degree of formality in the execution of any SE process activity is determined by the following. 1. The need for communication of what is being done across members of a project team, across organizations, or over time to support future activities. Number 2, the level of uncertainty. Number 3, the level of complexity. And number 4, the consequences to human welfare. And again, those were the appropriate degree of formality in the execution of any SE process activity were determined by those 4. On smaller projects where the span of required communications is small, with very few people and short project life cycle, and the cost of rework is low, SE activities may be conducted very informally and thus at low cost. On larger projects where the span of required communications is large, such as where you have many teams that may span multiple geographic locations and organizations and a long project life cycle, and the cost of failure or rework is high, increased formality can significantly help in achieving project opportunities and in mitigating project risk. In a project environment, work necessary to accomplish project objectives is considered in scope. All other work is considered out of scope. On every project, thinking is always in scope. Thoughtful tailoring and intelligent application of the SE processes described in this handbook are essential to achieve the proper balance between the risk of missing project technical and business objectives on the one hand, and process on the other hand. Chapter 8 provides tailoring guidelines to help achieve that balance. And then here's a list of figures. A list of tables. And that's the end of the preface.